Hi everyone, in today's lesson we're going to talk about limits day 4. Our goal for today will be to evaluate a limit that results in 0 over 0 or a hole, and we'll now use common denominators to dig ourselves out of that hole. So before we can do that, I want to just review how to find a common denominator. So let's just say I wanted you to add 1 over 2 plus 1 over 5. You'll recognize that these two do not have the same denominator. So normally to make the same denominator, you multiply top and bottom by what the other side doesn't have. So this needs a 5, this needs a 2. So you would do 5 times 1, that would give me 5 over 10, plus 2 times 1, which is 2, so 2 over 10. And we add the tops and keep the bottoms the same, so the final answer would be 7 over 10. So the concept of multiplying, adding the top, keeping the bottom the same, is something that you want to use when we have letters. So let's just say I give you a different example. Say I gave you 1 over x plus 2 plus 1 over 5. So same concept, but now I have x's involved. So this has an x plus 2 and this has a 5. So this needs a 5. And this right side needs an x plus 2. So whatever you do to the bottom, you do to the top. So you multiply the tops, 5 times 1, which is 5. And the bottom we're going to leave as 5 times x plus 2. You don't have to distribute. Then plus 1 times x plus 2 is just x plus 2. And the bottom stays 5 times x plus 2. And when you add fractions, if they have the same denominator, which they do, you keep it the same, 5 times x plus 2, and you add the tops. So 5 plus x plus 2. We can't add all of them, but I can add the 5 and the 2, so I'll make it x plus 7. And that is how we add with variables. So let's try a limit now. Problem number 1 says, evaluate this limit as x approaches 0, algebraically. So again, the picture is not going to be there, but I wanted to show you what it would happen. So I want to find it as x approaches 0. So if we look, here's 0 as x approaches 0. The limit from the left and the limit from the right are the same. And it looks like that y value is -4. So let's see if we can get that. So just like usual, our first step is always direct substitution. All right? So I want 0 over 1 plus 2 plus 0 minus 1/2. So 0 over, and this 1 over 2 plus 0 is 1/2, minus 1/2, which is 0. So 0 over 0. So we have a hole, right? That's something that we know by now. 0 over 0, we have a hole. So step 2 would normally be something like factoring conjugates, but I've got all these fractions here, so we're going to have to use common denominators. Okay? Common denominators. That will simplify it, and then our last step, step 3, will be to try again, as always. So let's see what we have. I'm going to rewrite it over here. So x over 1 over 2 plus x minus 1/2. So this is my bigger fraction, this guy right here. So I need to find the common denominator of this entire denominator. So if we can follow what I did before, this side needs a 2 plus x. Whatever I do to the bottom, I do to the top. And this side needs a 2. So if I want to rewrite this, this still has the x on top, over. So 2 times 1 is 2, over 2 times 2 plus x, keep that the same, minus 1 times all of this is just 2 plus x, over 2 times 2 plus x. So since the denominators are now the same, we can add them. So we're going to keep the top the same, so x over, and then the bottom is 2 over 2 plus x, right? That's going to stay the same. And we're going to add these tops. But notice how there's a minus. So I'm going to change that because we have to technically distribute it. I'm going to change it to a plus and -1, right? That's the same thing. Negative is the same thing as plus a negative. So I'm going to distribute this. So the top is 2 minus 2 minus x. So it should be, these cancel, 2 minus 2. So we have, I'm just going to put a big equal sign there, x stays on top, and the bottom is -x over 2 plus x. So the goal is to simplify this x over this. So you have to remember, when you divide fractions, we keep change flip. So we keep the top, which is x, or x over 1, change the division, this guy, to multiplication, and we flip the last fraction. So we're flipping this x and 2 times 2 plus x. So the 2 times 2 plus x goes on the top, and the bottom is -x. So what you should notice is that these cancel, and you're left with a -1 on the bottom. So the final answer is 2 times 2 plus x over -1. And if you want to simplify it more, you can divide these two and make it a -2 times 2 plus x. But if you can't see that, that's all right. You can just leave it in this form. So we're going to try again that last step. So we're going to take the limit as x approaches 0. And now we're going to put -2 times 2 plus x. So we're going to substitute 0. So -2 times 2 plus 0, which is -4. All right, I know that was a lot to take in, so I want to just recap. The direct substitution is always our first step. If we get 0 over 0, that means we have a whole. If we have fractions, we know we have to use common denominators to simplify. And then our last step will be to try to resubstitute it back in and get our final answer. Now, I know the common denominator part is probably the hardest, but don't worry, I have another example for us to try. Okay, so what I'd like you to do is try this one on your own. I would suggest trying the direct substitution and the common denominators, and then hit resume when you're ready for the answer. If you think you can't do it on your own, then listen for the directions now. So, step 1 is always direct substitution. So, we want it as x approaches 0, it says. So 1 over 1 plus 0 minus 1 all over 0. So 1 over 1 minus 1 over 0. So this is still 0 over 0. Life is beautiful. We have a whole. So if we look at our graph, I didn't even do that. The limit from the left and the limit from the right look like they came to the same spot. So the limit should be -1. So let's see if we can get that. So after direct substitution is step 1. Step 2 is going to be to use common denominators. All right, so I'm going to rewrite it. 1 over 1 plus x minus 1 all over x. So to make life easier, I'm going to put this 1 over 1. And then to make the common denominator, just like we did before, we give the other one what the other side doesn't have. So this needs a 1 plus x. Whatever I do to the bottom, I do to the top. And this needs a 1. So the bottom is going to stay x. That's not going to change. And I'm going to multiply 1 times 1. So that gives me 1. And then I multiply this times 1 plus x, which is just 1 plus x, minus. But since there's a minus here, you have a choice to change it to a plus. So I'm going to do that. I'm going to make it plus a negative, and I'm going to distribute this out. So that would be, if I changed it to a plus, then I'm going to change that to a plus. And I'll make this negative 1 minus x, because I distribute. Negative 1 times positive 1 is negative 1. Negative 1 times positive x is negative x. Multiply these two bottoms together, and I get 1 plus x. So the denominators are now the same. So since they're the same, I write one of them when I add them together. And let's add the tops. So it's 1 plus negative 1 minus x. So all of this. And you should notice that this 1 plus negative 1 will cancel. So I'm left with negative x over 1 plus x all over this original value of x. So this x is here and here. So now we have a fraction that we're going to keep, change the division to a multiplication, and then flip this last one. So we're going to keep the negative x over 1 plus x, change the division to a multiplication, and flip it. So let's write it x as x over 1. And when we flip that, we get 1 over x. We should notice that these x's cancel. And we're left with a negative 1 on top and a 1 plus x on the bottom. So that's my second step. And then my last step, step 3, we're going to try again. So, limit as x approaches 0 of negative 1 over 1 plus 0. Just for purposes of space, I just substituted the 0 in here. So negative 1 over 1 reduces to negative 1. And as we looked, that was our final limit. All right, so let's add to that limit flowchart. This should be the last thing that we need to add. So again, first step is always direct substitution. Then, if you get a number, life is beautiful and you're finished. If you get 0 over 0, that means we have a hole in the graph. The way to get rid of a hole, those three things that we've talked about the past few days are factoring, conjugates, and now common denominators. So when you have a hole, you have to decide whether I'm going to use factoring, conjugates, or common denominators. And then the last thing that you want to do is try again. And when you try again, you should be finished because you should get a nice, pretty answer. Sorry, that's a smiley face. But that's the idea behind the flowchart. All right, that's it for today. If you have any questions, please let me know.